Hi! Despite the extensive Angular ecosystem, there are still use cases when we have to adopt a certain third-party library that doesn't provide any Angular wrapper, or the wrapper is simply outdated. In this video, we're going to cover exactly this use case. We will adopt a third-party JavaScript library that simplifies the process of the file uploading, and we're going to integrate it the Angular way. We will create a separate Angular library that will be working as a wrapper around the library we want to integrate, and this wrapper will expose a modern standalone API, helping us seamlessly integrate the third-party library and make the configuration extensible, reusable, and configurable. I am Dmitry Mrzhensky, and I constantly publish advanced Angular tutorials, tips, and courses, helping you to become advanced Angular developers. Feel free to explore my YouTube channel later, but now let's jump straight to the point. So here is my application. It consists of a single button. Clicking it opens a dialog window where you can select and upload an image from your computer. Once the upload is complete, a preview of the image will appear here below. As I have already mentioned, I use a service called Filestack to upload files. They provide a JavaScript SDK to simplify the process of file uploading, transformation, and so on. Filestack is a paid service, but as a sponsor of this video, they have shared a special link with me, which you can find in the video description. This link will give you a 21-day free trial, which is more than enough to try it out. The integration of Filestack is very straightforward. The only thing you have to do is to sign up, clicking this button or using my link in the video description. And after that, you will see the developer portal like this one, where you need to find and copy your API key. Then you can go to your web application. In my case, this is a simple Angular app, and simply install the JavaScript SDK for Filestack by installing the Filestack.js library. Then just import the necessary functions and types from it, and you are ready to go. There you can see that I call the init function with the API key I just copied, and in this way I initialize the Filestack client. After that, I configure the picker. This is basically the dialog window you see when you click the button, and there I configure it in such a way so that only PNG and JPEG files are allowed to be uploaded. In the onUploadDone callback function, I perform certain actions when files are successfully uploaded. After that, whenever the user clicks the button, I open the picker, and when everything is uploaded, I simply accumulate the uploaded files inside the uploads signal. After that, I simply iterate through the uploads inside the component template and display the list of uploaded files. As easy as that. Right now, I'm integrating Filestack SDK directly into my Angular app. It works, but this is not an ideal solution, and this is why. First, Angular dictates the architecture and patterns we have to follow to structure our code. But the Filestack SDK is a generic JavaScript library, and it doesn't respect the architectural language of Angular. So the integration feels a bit out of place. Second, we are directly depending on the Filestack client in the component. That breaks the open-close design principle and makes it harder to replace the implementation of the client at runtime. And the third issue is the lack of the centralized configuration, because right now all the setup, like initializing the client and configuration of the picker, it is hard-coded inside the single components. And in the next 20 minutes or so, we will try to get rid of those issues. Before we start, I just wanted to mention that if you prefer, you can keep everything under a certain folder in your application. That's totally fine. But I will show you how it would look like if you decide to move the wrapper logic into a separate Angular library that wraps around the Filestack JavaScript SDK. To do that, we would need to generate a new library, and Angular makes this process very easy. You can use the ng-generate library command right from your terminal, and execution of this command will scaffold a basic Angular library for you. Once it is created, we will do a bit of cleanup and I'm going to add some missing stuff. So first, let's make sure that we add Filestack.js library as a peer dependency. This is important, especially if you plan to publish this library somewhere to npm. And a peer dependency means the dependency that is required by a library to be installed in the project where your library is going to be used. So in my case, Angular core and Angular common packages, as well as a Filestack.js, they are required. Good. So next we can remove the auto-generated files because we will be writing our own files from scratch. And because of that, we have to also clean up the public API exports as well. And after that, you might see the TypeScript error inside the config, which says that, okay, they're missing some properties like source map option is missing. So let's fix that and just add source map with the value true to the TypeScript config. Once that is done, I'm going to go and build my library in watch mode by providing the watch flag. So every time I make changes in the library source code, the library gets rebuilt and automatically the changes will be reflected inside my application that will be relying on this library. Once the library is created, I can start moving some of the logic from my component into it. So I will begin by extracting the Filestack client configuration and initialization. And my goal is to make this process reusable and extensible. And that's why I'm going to create a special provider function that handles this logic and follows the modern Angular Standalone API. So let's go ahead and create a new file inside our library called provider.ts. In this file, I will export a function named provideFilestack, which takes an API key string as a parameter. We will add the actual logic for this function in a moment, but for now, let's go to the public API file and replace the placeholder export. Instead, I will export everything from the provider.ts file. Great. And now let's get back to the provider.ts. There are two things we need to do here. First, we have to create an abstraction layer for the Filestack client so that users of the library can easily replace the implementation if it is needed. Secondly, I'm going to add logic to the profile Filestack function, which will initialize the Filestack client and register all necessary providers and injection tokens. So let's go through them one by one. For the abstraction layer, I'm going to create an injection token. This token will represent the Filestack client instance, so the type of this injection token will be the client interface, which comes from the Filestack.js library. Now, inside the provideFilestack function, we will return an array of Angular providers that are needed to make Filestack work. In this case, we will provide the Filestack client token and the value will be the result of the Filestack init function. Since this is custom logic, I'm going to use the useFactory dependency provider here, and the actual initialization logic we can go and grab from our app component and just move it inside our provider. Now we just need to replace the hard-coded API with the argument that we will provide later as an argument for this provider function. And by the way, while initializing the client, we can also path a config object and configure additionally the Filestack client. So let's extend our provideFilestack function to take a second argument called options, which can be optional. And then let's just pass it to the init function right here. And before we test our implementation, here is a pro tip. So if your provider function is meant to register global application providers inside the root injector of your Angular application, like in my case, you can wrap your providers array here in the make environment providers function. This function makes sure that your providers will not accidentally be referenced in the components injector or anything like that, which might lead to unexpected behavior. Great, now we are ready to integrate it into our application, and it is actually super simple. Just go to the app.config.ts file in your Angular project and somewhere here above import the function we just created. After that, next to your other providers that you might have in real application, you have to call the provide Filestack function and pass your API key. And optionally, of course, you can provide the config object for the Filestack client if it is needed. For example, you might want to disable error forwarding to third-party error handling services like Sentry or anything like that. This everything you can configure here. Awesome. And now we can go to the app component, and instead of initializing the Filestack client directly, we just inject the Filestack client injection token that performs initialization and returns already the configured client instance. And if you save everything and go to the browser, you will see that our application still works exactly the way as it was before. But now our code is much cleaner and flexible because first, we are no longer breaking the open-close design principle because we are depending on abstraction, not the direct implementation. Secondly, we now have a single place for configuration and initialization inside the app.config.ts file. This setup is global and easy to adjust thanks to the provide Filestack function. However, a few limitations still remain. Even though we added a basic abstraction layer, we are still interacting directly with the Filestack client. That might not be necessarily a bad thing, but in my case, I potentially might need to repeat same actions when I want to reuse my picker. For example, what if I want to allow uploading of PNG and JPEG files by default, but still have an option to override this rule in some certain cases? And this is where additional abstraction layer like dedicated Angular service could come in handy. So let's try to implement it. So let's go ahead and create a new file inside our library. And I'm going to name it filestack.js. Here we will create a super simple Angular service that will be automatically provided in the application's root injector. And also, this notation makes this service tree shakeable. Since the part of the service responsibility will be Filestack picker configuration, let's create a dedicated method for that, and I'm going to leave it empty so far. This method will receive additional picker options as an argument, so let's import a corresponding picker options interface. And of course, we will not be able to configure the Filestack picker without the Filestack client. So we need to inject the Filestack client itself, and we can do it right here above. As I mentioned earlier, I would like to also define some basic picker options that will be applied by default for every picker config, even if user doesn't provide any configuration for it. Namely, I want to have a part of the picker configuration I use currently in my app component, and I want that these file extensions will be allowed for uploading by default. So let's grab this part of the configuration and paste it inside the base config object. The idea is that when we call configure picker method from this service, it will merge the base picker options we recently created with any options provided by the consumer of the library. And eventually the picker will be configured with this merged config, right? And here the order matters. The options provided by the library consumer should come last, so they can override the defaults if it is needed. So let's go ahead and let's configure the picker using the merged options, and then I'm going to return the instance of the configured picker. That's it. Simple and clean. Now let's save our changes and go to the public API file of the library. And from there, I'm going to export everything from the Filestack.ts file, so our new service is available to library consumers. In the next step, I'm going to go to my application, and instead of injecting the Filestack client directly using the injection token, I will inject the Filestack service that we just created. This means I'm no longer able to call the native picker method from the client, and instead I'm going to call the new configure picker method from my new service, which comes with the pre-configured options. And because the service already has some base configuration which partly matches the one I provide here, I can now remove that duplicate part of configuration from here. And I will just keep the logic that is specific to this use case and this component. Now, if I save the change and go and check my application in the browser, everything still works. And as you can see, I can still pick and upload JPEG and PNG files, and they are successfully uploaded as it was before. Even though introducing of the Filestack service slightly improved our code, it also brought a bit of confusion, right? Because now we are exporting both the service and Filestack client injection token, and that might leave users of our library unsure about which one they should actually use. Sure, you could explain everything in your documentation, but let's be honest, who reads documentations? No one. So as library authors, we should expose only the API that encourages the proper usage of our library, and everything else should remain private. Of course, this API and design decision is up to you and depends on your particular case. But let's say that in my particular scenario, I want to expose only Filestack service, and in such a way, I force library consumers to interact with Filestack only through the service. So how can I do that? For that, you have to go to the public API TS file, and instead of exporting everything from a provider file, I only expose the provide Filestack function, and that's it. And once I save this change, I will immediately get an error in my app.ts file because the Filestack client token is no longer available for the import. So I have to remove this import to make my application work. So in such a way, I could control which API is private and which one is public, which makes eventually my library much safer and less confusing for the library consumers. However, there is still one issue left. The thing is that for every project where the library could be used, the default list of allowed file extensions might be different. But right now, we have hard-coded this array directly into the Filestack service. That's a problem because it also breaks the open-closed design principle, because we cannot change or extend that configuration without changing the source code of the service itself. So what we should do instead is to allow users of our library to configure their own default picker options. And I'm going to solve this using Angular dependency injection again. I will create a special injection token inside the provider TS file, And this token will let consumers to override their default picker settings. So I will add a new token called Filestack base picker options. It will be an injection token with the type picker options. As simple as that. In the next step, I'm going to make this token as a part of my library public API. So I'm going to expose this token inside the public API TS file so users can import and use it in their applications. And then I will go to the Filestack service and slightly update its logic. And instead of hard coding the default picker options, I'm going to inject the token I just created, and I would like to also make it optional. So if nothing is provided by the library consumer, then they will be used just the empty object as a configuration. And after that, the library users can simply provide their own default picker settings inside their app config TS files. For example, they can register a provider for the Filestack base picker options injection token, and then using the use value dependency provider, we can provide our custom default picker configuration. So let's say that in my case, we want to accept only JPEG files by default, and now I can save my changes and test it. So if I open the picker, you will see that only JPEG files are available for selection, and PNG or SVG files, they are disabled. So it works just as expected. All right, so this is how the integration of the third-party non-Angular library could look, and I hope it could give you some direction on how to proceed in similar use cases. And of course, this is kind of never-ending story, and we could keep going and continue bringing more and more improvements to our wrapper library. For example, we could extract the user interaction logic into a separate building block and expose a familiar input-output interface to make the integration with Angular even smoother. But since this video is getting already too long, I'm going to stop it right here, but I'm going to show a couple of cool improvements that you could add to our wrapper library in the separate video that will be available exclusively for YouTube channel members and also those who support me on Patreon. And also, channel members and patrons are watching this video much earlier. And if you want to unlock such opportunities as well, in the video description, you will find all the information. Anyway, thanks for watching this video until the end. I hope you learned a lot of cool stuff from it. And if so, please share this video with your colleagues and friends. And if it is your first time on my channel, check it out, check my other videos, and don't forget to subscribe to not miss future advanced Angular tutorials. If you want to level up your Angular skills to entirely new level, please check out in the video description. There is a link to my video courses where you can learn a lot of advanced Angular topics in details with source code investigation and a lot of cool stuff you can find there. Besides that, I run my Discord Angular community. You can join it for free, and we are already thousands of Angular developers around the world having fun there and participate in different discussions about Angular. So you can scan this QR code, and we are looking forward to meet you. Otherwise, I wish you a productive week ahead, guys. Stay safe and see you in the next video.